We'll be looking at problem 5.62 on page 314, shooting free throws. It says a basketball player makes 70% of her free throws in a long season. In a tournament game, she shoots 5 free throws late in the game and misses 3 of them. The fans think she was nervous, but the misses may simply be chance. You will shed some light by estimating a probability. And this is a common occurrence in sports. Whenever something happens that's perhaps slightly less probable, people often attribute it to the player choking. They weren't able to perform under pressure, when it might just be that occurrence will happen in some number of trials. So in this simulation, we're going to see how likely that outcome was. When we begin with a simulation, we will start by labeling numbers for whatever the particular outcome is. So since our free throw shooter, she is a 70% free throw shooter, we will label the digits 1 through 7 as success, where success in this context is making a free throw, and the digits 8, 9, and 0 are a failure, and that is a miss of the free throw. And to simulate these 5 independent shots, to simulate the 5 independent shots, we will select 5 single digits from line 125, that's as noted in part B of table B, or random digits in the back of the book, and assign outcomes as described. For example, the first set of 5 numbers is 9, 6, 7, 4, 6. That would map to, well, 9 is a miss, a fail, but 6, 7, 4, and 6 are all successes. So this set of 5 digits would map to 4 successes and 1 failure. That is, our free throw shooter made 4 and missed 1. Part B says simulate 50 repetitions of the 5 shots and record the number of missed on each repetition. Use table B starting at line 125. What's the approximate likelihood that the player will miss 3 or more of the 5 shots? I'm going to copy down the first 5 set of numbers. We have 9, 6, 7, 4, 6 as previously shown, 1, 2, 1, 4, 9, 3, 7, 8, 2, 3, 7, 1, 8, 6, 8, 1, 8, 4, 4, 2. And each one of these I'm going to count the number of fails, the number of misses. That is, I want to count the 8s, 9s, and 0s in each set. Well, in this first set of 5, we have 1 9, so this would be 1 miss. In the second set, again, 1 9, 1 miss. In my third set of 5, 1, 8, 1 fell. In my fourth set, I have 2 8s, 9s, or 0s. In my fifth set, I have only 1 8. So, through our first 1, 2, 3, 4, 5 set of 5 free throws, the player only missed 1, 1, 1, 2, and 1. So, she has yet to do what she did in the game, that is, miss 3 of 5. So, maybe this is a quite improbable situation. Maybe she was indeed nervous. The book asks us to do 50 of these. So pause the video now and complete 50 of these repetitions. Okay. So hopefully you've completed the 50 repetitions, and I'm going to show my results at this time. So this problem, as you can tell, took a little while. And this is certainly a problem where having some sort of technology to perform this simulation for us might have been helpful. We're now going to make a dot plot and show the likelihood of our particular situation. So I'm going to graph the number of missed free throws out of 5 in any particular set. All right. Zero, 1, 2, 3, 4, 5. Again, our variable of interest here is number of misses out of 5 free throws. Okay, so I begin by counting the sets of 0 misses. That is, the shooter made all 5 free throws that they attempted. 1, 2, 3, 4, 5. Now the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Alright, now twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Last the threes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so looking at our distribution, it's relatively symmetric. You can see that there's more ones than anything else. Does that make sense? Well, we're looking at the number of misses. Our free throw shooter has a 70% chance of making it, so 30% chance of not making it. If we're shooting 5 free throws, 30% of 5 is 1.5. So yeah, that does seem reasonable that 1 would be the most, 1 and 2 would be the two most likely outcomes. We had, interestingly enough, no 4 or 5 misses. Obviously there's a chance of that happening, but in our 50 trials it did not occur at all. So the question is, what is the chance that our player would have missed 3 or more? Well, we had 10 of exactly 3, none of 4, and none in 5. So our experimental probability in this case was 10 out of 50, which is 1/5, which is 20%. So in our experiment, 20% of the time the player would have missed 3 or more, so 20% of the time is a relatively likely occurrence. This is pretty strong support of not nervousness, not choking, just an outcome that would have happened. Okay, a couple of additional notes from this problem. As always, we usually need one sentence written in context that summarizes our results. So here that is. In our simulation, the shooter missed 3 or more of the 5 free throws in 20% of the trials. Additional notes to this problem. The book answer is 11 out of 50. So perhaps in my simulation I failed to catch one of the 3 or more missed free throws. I counted 10 out of 50. The book says 11 out of 50. You look closely and see what you get. Lastly, this is indeed a simulation. In Chapter 8, in Chapters 6, 7, and 8, we'll discuss probability. In Chapter 8, we will specifically discuss the binomial distribution. And this particular situation is a binomial setting. We will figure out what the theoretical probability is for this. And we will see that it's relatively close to 20%. So perhaps when we get to Chapter 8, we will revisit this problem.